Hello, welcome to the Hurricane STEM Science, Mitigation, Preparedness, and Emergency Management Education Learning Module for sixth graders. I'm meteorologist Eric Salna, and I am Associate Director of Education and Outreach at the Extreme Events Institute in the International Hurricane Research Center at Florida International University in Miami. And this learning module is all about hurricane and science and preparedness, and it's going to connect the dots with emergency management. What is emergency management? What's its role in the community, and what do they do, especially when a hurricane is threatening our area? So we'd like to graciously thank the Florida Division of Emergency Management for graciously supporting, in large part, this community education outreach project, where we're going to learn about, as we said, what emergency management does and its role in helping the community. So STEM education, well, as many of you know, that stands for science, technology, engineering, and math. And a lot of this content is going to be related to STEM. So first of all, the science of weather. What is that? Well, the science of weather is meteorology, which requires math classes and lots of science classes, including things like physics and chemistry. And that's what I took as I became a meteorologist myself. And meteorology is certainly a STEM career opportunity involving science, technology, engineering, and math. So as an opportunity for students to think about. And meteorology is the study of weather and climate across the entire Earth. So we want to talk about the Earth and its relationship with the sun. It's the sun's energy which drives all the weather on the planet Earth. And that energy, heat energy, comes through space from the sun and interacts with the Earth and starts to create differences of temperature. And we have this transfer of heat, warm areas and cooler areas. And those differences between temperature, warm and cool areas, will start convection currents. The air will start to move from areas that are warm and cold because pressure differences start to present themselves, high pressure and low pressure. But these convection currents are started through all that solar energy coming from the sun. So you can have these convection currents in the atmosphere, and you can have them across the oceans of the Earth. As the ocean interacts with the sun's energy, and you have these ocean currents all across the Earth, and all the different oceans start to form as the water starts to circulate. And that's important too, both atmospheric and ocean currents when it comes to clouds and thunderstorms and eventually hurricanes. And we all know it's related to the water cycle, where you're going to have that sun's energy hit the water, you'll have evaporation. That air that's full of moisture rises to a certain level of the atmosphere where the air cools as you rise in height, and you'll have condensation, and you'll start to see all those particles reform and be part of a cloud. And then if you have so many of them, they're going to have to start falling as precipitation. So that evaporation, condensation, and then precipitation, a big part of the water cycle. So you can see here on this diagram showing a typical cloud along a sunny Florida beach, and see how that water cycle right before your eyes happens with that evaporation, condensation, and then you're going to have that precipitation, all having to do with that sun's energy. Now for that, we'll go to the weather scoreboard. This is important. Which U.S. state in the whole United States ranks #1 with thunderstorms, lightning, and hurricanes? Well, the answer is Florida ranks #1 in all of them. So it shows you how vitally important this information of weather science and weather safety and preparedness is so important for all Floridians and people beyond Florida for sure. But since we get these hazards, it's very important for all of us as students, sixth graders, and teachers to understand. And since we are the lightning capital of the United States, lightning safety is so very important. So it's very easy, lightning safety rules. Just get inside your house, your school, a store, a car, get inside, stop swimming, get out of the pool, get off of the beach, get off of the football field or soccer field. You don't want to be a target for lightning. All right, now we're going to get into hurricane science. So when does the hurricane season start and end? Well, it starts June 1st and ends November 30th. And if you do the math, that's 6 months. That's half the year that we need to be prepared and ready to go if a storm should come our way. Do we name our hurricanes? And the answer, of course, is yes. And this is the list from the 2020 Atlantic hurricane season, which was a record-breaking season. This is just a snapshot of all the storms we had in 2020. And here are the names. So first of all, there's 6 lists of names that we rotate every year. So last year's list started with Arthur and ended with Wilfred. Well, usually that's enough names to cover a hurricane season, but not in 2020. It was an active season. We ran out of names. So the National Hurricane Center had to go to the emergency backup alphabet list, and that was the Greek alphabet, to keep naming storms. And we started with alpha, beta, gamma, went all the way to iota. And then finally, the storm stopped forming. We've never had to go to the Greek alphabet before since 2005. So we've only done it twice in history, and we never want to do it again. And now they decided we're not going to use the Greek alphabet as an emergency backup. They are now creating a brand new list of names to be on standby to use if we ever run out of the primary names in the primary list. And again, we don't want to ever see that happen again, at least hoping for that. So now here are the numbers. So look at the named storms, hurricanes, and majors. An average season sees 12 named storms, 6 hurricanes, and 3 majors. Well, in 2020, look at this. We had 30 named storms, 13 hurricanes, and of those 6 were majors. Record-breaking season. Now here's all the tracks. And look at all these tracks that came towards the southeast part of the United States. So why did that happen? Well, a big part of that is what we call steering currents. And in the middle of the summer in the Atlantic, we have a big area of high pressure, and winds blow counterclockwise around an area of high pressure. And it was positioned just right to help steer the storms towards the southeast part of the country. Now here's one of the storms from last year. This was Hurricane Eta, and this hit Central America. And when we think about hurricanes, we want to think about how can they form? What do you need to form a hurricane? Well, you need ingredients. You need a recipe. And here's the recipe that we have for creating hurricanes. So first of all, I have here warm water, ocean water. You need lots of warm ocean water to act as fuel for the storm. A moist atmosphere, lots of moisture. That's so you can form those clouds and the thunderstorms. Need an area of low pressure to form, or a tropical disturbance, area of low pressure and thunderstorms, and that helps start the process. And then no wind shear. Now, what is wind shear? Well, wind shear is wind that changes with direction with height and changes in wind speed with height. And that makes things really turbulent. Hurricanes don't like that. Hurricanes want a calm atmosphere above it. So they don't want wind shear. And now some of the other ingredients that we had last year. West African monsoon. We have what's called a rainy season every year. They have a rainy season in West Africa, and they call it the monsoon. And then we had lots of low surface air pressures across the Atlantic. And then we had what's called La Nina. La Nina is in the Pacific Ocean, not the Atlantic. And that's where you have the water gets colder along the equator, and that's called La Nina, and that can affect our hurricane season. Very interesting how what can happen in the Pacific Ocean can affect what happens in the Atlantic Ocean. And the opposite of that is called El Nino, where the waters are warmer than average, and that can make for a slower hurricane season. But we had La Nina, which made it for a more active season. And when you have all those convection currents and have all that moisture, you're going to start to see those convection currents, and you're going to see the water cycle start to happen and start to form those clouds, showers, and then thunderstorms, and then more and more into the development of a mature hurricane. So the life cycle of a storm. We have what's called a tropical disturbance, that area of low pressure and storms that form at first. Then you go to what's called a tropical depression. It gets a little more organized. And then from there, we go to a tropical storm strength. And then that's when it gets the name. And if it continues to intensify, we go to the next phase, which is hurricane. And then category 1, 2, 3, 4, or 5. And that mature hurricane structure will have spiral bands, will have an eye in the center, big outflow out from the top of the storm. And it's a natural process of the earth. Hurricanes are a natural way to release heat energy, energy that's coming into the equator, all that solar energy that's hitting the earth in the summertime, and that air, which will help then create those air and ocean convection currents. So that release of energy is a natural process of the hurricane season. All right, so what are the weapons of a hurricane? Well, there's storm surge, rip currents, tornadoes. We have flooding rains, and we have strong winds. So the winds, we have a scale that measures those winds. It's called the Saffir-Simpson Hurricane Wind Scale. It's called categories, 1 through 5, 1 being the weakest, 5 being the strongest. Storm surge, that's when you have the water at the beaches. Literally the hurricane, its brute force and momentum in the wind pushes that water across the beaches into those inland communities, and they start to flood. And that can be life-threatening. And so the National Hurricane Center now issues storm surge watches and warnings if there's going to be storm surge. Storm surge watch means there's the possibility of storm surge within 48 hours. And the warning means there's the danger of storm surge within 36 hours coming to your community. And that means people got to go. That means people have to evacuate. So you want to think in terms of who has to evacuate during a hurricane threat. And it's anyone living right along the beaches that'll be threatened by storm surge. The other weapon is flooding. We can get 10 to 15, 20 inches, even more from a hurricane. And that will be flooding everywhere on the roads and highways. So you don't want to drive through that, and you don't want to walk through that either. And then the last weapon, rip currents. Strong winds onshore, blowing onshore before the storm hits. And you may have heard about rip currents, and you'll see these diagrams at all the lifeguard stations along our beaches. It shows you how to get out of a rip current. And I've been caught in one too. So this shows the arrows. A rip current will take you out to deeper water like it did to me. It's natural to think that I just want to try and swim against it and fight it. But that's not what you want to do. You want to swim out of it by swimming to the right or left or parallel to the beach. Then you get out of the rip current, and then you can safely swim back to the beach itself. All right, we need information about the storm too, right? So question is, does anyone fly into hurricanes? And the answer is yes. They're called the hurricane hunters. We have the NOAA hurricane hunters, and they fly a couple of different kind of aircraft. This is a G4 jet that flies way above the storm to get information above the hurricane. And then we have this P3 aircraft, or propeller aircraft, that doesn't fly above the storm. It flies through the storm to get information. And where are they headed? They're headed for the eye. And that's where they want to get information about the storm. Look at this picture. This is what the inside of the eye looks like of a well-developed hurricane. It's nicknamed the stadium effect. It's like if you go to a football game and you're at the 50-yard line, you look all around you and see the stadium. Well, that's what the hurricane hunters see. And that's calm, it's clear. And to get to that eye, they had to fly through this eye wall, the most dangerous part of the hurricane. And to fly through that eye wall, extremely dangerous. And think of a roller coaster ride, and you're bouncing all around and everything else. And it's the planes are strong, but it's a very turbulent flight. And then they get into the eye, and then they have to fly to the other side and do it all over again. Here's another picture showing you sunshine, clear skies in the eye itself. Incredible pictures. And this is how they're getting the data. They're dropping this instrument package called a drop sonde. It literally has an instrument package, and it has a parachute. So they'll drop it out of the back end of the plane, and it'll literally float, float, float all the way down till it hits the ocean surface. And that instrument package, it's getting data, information, temperature, humidity, pressure. And we're getting wind speed and direction as well by its trajectory. And all of that is fed then to the National Hurricane Center, who forecasts our hurricanes. And they also are flying now drones, and they're doing research with drones to see how these drones can fly at the lowest, most dangerous levels of the storm to get information as well. And here on the campus of FIU, we have the National Weather Service and the National Hurricane Center. They're both located in this building, and the National Hurricane Center has the responsibility of forecasting all the hurricanes, and the National Weather Service then takes that data and then lets us know how it'll affect us in our forecast. Notice how that building is built. Very important. It's built of concrete. We don't want that building blowing away during a storm if it ever should come to South Florida and Miami. So they need to continue to give us that valuable information. So they're the ones that create what's called that hurricane forecast cone. It's what we see on television when a storm is coming. So how is this cone created and what's in there? Well, here's a cone that was created in 2017 from Hurricane Irma. And the cone shows us geography. Where will that storm be every 12, 24 hours, 48 hours, 72 hours and beyond? And it could be anywhere in that cone in that time frame. And then you have these dots. And you have the dot, you have a letter, an M. That stands for major. So it was predicting Hurricane Irma to be a major storm as it approached Florida, which it was. And these red areas are showing you where all the hurricane warnings are. So it can show us now a diameter of hurricane force winds, diameter of tropical storm force winds. So it does give us information, but it doesn't give us all the information that we need to know. So how is that cone created? Well, remember that dropped into the storm, it's collecting data. That's fed into computer models. Those computer models use a lot of math and physics to try and predict track and intensity. And for track, you have all these lines predicting a track. And we wish there was one model that predicted the best track. So then on TV, all we would see is just a skinny black line. Well, unfortunately, we don't have just one best model. We take an average of all of them. And what the Hurricane Center does is encircle all those models to create the cone. So that's how we create the cone. So we see what it shows us, but what it doesn't show us is information on the hazards. And the hazards, we have to look to other graphics where find out how the intensity of the storm surge watch and warnings, the heavy rainfall, those things are found in different graphics. And during a storm situation, we'll be under a hurricane watch and warning. Hurricane watch, you may remember, is hurricane conditions are possible in 48 hours. Hurricane warning, conditions are expected in 36 hours. And then when there is a storm, you can go to the National Weather Service for that local information, because they will show you specific graphics, specific for your area. And that's very important to show you the impacts, the threats and impacts of that hurricane as it approaches. All right, from hurricane science, we go to hurricane research, which is what we do at FIU. And this is another STEM career opportunity, and it's all about wind engineering. And how we do that is through the wall of wind. And these are 12 giant fans that we have at FIU that we can create up to a Category 5 hurricane, all for research. And we put water in the system sometimes too to replicate rainfall from the storm, because hurricanes can bring like 8 to 9 inches of rain per hour. And it's all part of a national network through the National Science Foundation. It's called NIHRC, and we're one of the experimental facilities doing wind engineering studies. And here's a video to learn more about the wall of wind. Oops, we're going to go back in just a moment. Here we go. This is the video that we're going to start.
The 12-fan Wall of Wind facility at FIU, which we call the WOW, is the largest and most powerful hurricane simulation facility in a university setting that can simulate Category 5 hurricane wind, the highest rating on the Saffir-Simpson hurricane scale.
The Wall of Wind allows for wind loading experiments on various structures at multiple scales. And because it is an open jet facility, it is capable of doing destructive testing on structures to study their failure and collapse modes without the risk of damaging the wind tunnel. The Wall of Wind can do holistic system level testing. That means we can test structures with the components and connections as integral part of those structures and study the system level performance. We can also look at wind-driven rain intrusion into actual building envelope, and we can study progressive damage of the system. So this is a new way of looking at hurricane impacts on building systems, because building envelopes are one of the most vulnerable elements in hurricanes.
Here in the control room for the Wall of Wind, we can monitor a lot of the systems that are part of the Wall of Wind, but we can also control them. We can control our pressure scanning systems, wind speed measurement devices, load cells, force balances, transducers, and a lot of many other instruments that we have available in this facility. We also have a system with high definition cameras that we can see over here and record when a part of the model failed and how it fails.
Our safety program includes personnel safety, which includes trainings through the Environmental Health and Safety Department within Florida International University. Also includes safety protocol to ensure the safety of all equipment within the Wall of Wind.
The Wall of Wind is a very versatile wind testing facility. It can test up to speeds that are equivalent to Category 5 hurricane speeds, 160 miles an hour. And it also simulates the wind profile and turbulence of natural winds very well. So we have already tested, and we will continue to test, a wide variety of different research projects in this facility. For example, we have tested full-scale systems for roofing, like standing seam metal roofs, roof paving systems, tiles, shingles, and so on. Those can be tested essentially at full scale, and it allows us to look at the way the whole system performs under wind loading, as well as its interaction with the wind loading. So that's a very important role of this facility. We also have been developing techniques that are applicable to smaller structures, which we call partial turbulence simulation, which allows us to put relatively large-scale models in the facility, and we combine the test data with other analysis and computational methods to give us predictions that include all the big-scale turbulence that we may not be able to include at that scale in this facility. We've done testing related to the transportation industry. One example would be variable message signs. We've done a project here with a PhD student whereby we've refined the aerodynamic coefficients used in the AASHTO code and the gust factors, and we've looked at the phenomena of vortex shedding and galloping, which could cause vibrations of these structures at high wind speeds. That's another example of the application of this kind of facility.
One of the most important aspects of wind engineering research is related to codification of research findings. So here at the Wall of Wind, we test small, large, and full-scale models in order to extract those important information that we can use in order to enhance current building codes and wind standards. The codification process in these type of studies has a direct impact on people's safety and economic development of our community.
So the STEM Transformation Institute makes use of this classroom to allow students to learn about their sciences in the classroom as scientists. In this case, this is a bridge between the Wall of Wind and students learning in the classroom. So it brings the Wall of Wind straight into this classroom where students are going to learn about it through this active learning process.
Wall of wind was used to develop and validate various innovative mitigation techniques for lessening hurricane impacts on structures. One example is the validation of aero edge, which are edge devices that can be put on roof to reduce the wind uplift damage on roof components. This product was developed by the industry partner of the Wall of Wind and has been patented. Wall of Wind has proved to be a multi-user research infrastructure, both for national and international researchers.
The vision of the Wall of Wind facility is to significantly advance the state-of-the-art in wind engineering research and education, and to impart resiliency and sustainability to new and existing buildings, cladding systems, and lifeline infrastructure, so as to prevent wind hazards from becoming disasters.
All right, so now from getting an overview about the Wall of Wind, now we're going to look at this demonstration video, and there's no sound, so I'm just going to talk over the video. And this was a situation where a media team came and they wanted to see lots of destruction and a building blown apart. And we said, okay, we understand that, but we want to show people also how you can protect a building from being blown apart. So what we did was we worked with the team and we created a special little house, a little structure. And you'll see here we had, this is the structure we're talking about, and we put things in front of it like a bicycle and a barbecue grill. And the one side was a strong side. It had window metal shutters and then roof hurricane clips, you know, the straps holding the roof down to the building. And then the other side was the weak side. It had no shutters and no roof tie downs. And so we hit the house first on the strong side that was mitigated, and there was no failure, even up to Category 4 winds for only less than $250 reinforcement. Then we spun it around to that weak side and watch what happens. Catastrophic failure. Watch the roof flying through the air with no mitigation. Watch the flying debris. And this is what can happen as buildings get destroyed as a hurricane approaches a community. And that roof flew almost 200 feet in the air before it landed. So it showed quite dramatically this test on how you can prevent damage. And there's that roof landing on that concrete wall that stopped it. So the media team got what they wanted. They got destruction, but we got what we wanted, which was the teachable moment, showing you how you can mitigate and prevent damage to buildings. So for all the middle schoolers and sixth graders and teachers out there teaching this, this is the lessons learned here about research with hurricanes at FIU and how we can do more to build better and build stronger. So those wind engineers look at these structures, and as the wind hits it, there's forces of the wind, and can be positive or negative forces, and that affects the performance of the building. And then we have roof shapes. So we have a gable roof, we have a hip roof, and then a flat roof. Which one does best in a hurricane wind? Well, the answer is a hip roof, because it slopes on all four sides. It's more aerodynamic, and the wind goes up and over, and that's the best shaped roof when it comes to aerodynamics. All right, so now from hurricane science to hurricane research, now we go to hurricane mitigation and preparedness. So wind mitigation, we've learned what that is. It's protecting your home or school from a hurricane wind, and there's different ways to do it. This is a famous picture in Texas, how this house was built to withstand hurricane force winds. The other houses weren't. And look at this information. Every $1 you spend on mitigation saves at least $6 in damage and cleanup. So it makes good financial sense. So to hold that roof down, you need those hurricane straps. And if you go into an attic of a home here in Florida, you'll see these straps holding down that roof. Adds tremendous strength. Another area we have to be concerned about is houses that have big two-car garage doors. It's a weak link, if you will. If they fail, the wind gets in and can bring up the roof. So you want a strong code-approved garage door. And we have those here in Florida, have extra bracing against wind and debris. And that debris is what's dangerous, that flying debris. These are pictures, Hurricane Maria in Puerto Rico. Look at this 2x4 right through the palm tree. Another example of the same thing. So that flying debris, we need to then protect our windows. And we can do that either by wood, plywood, or metal. And of course, metal is stronger than plywood. So the recommendation is to go with the strongest product. But plywood is still used today, but be advised it's hard to put up correctly. And when you think about it, that flying 2x4 that went through the palm tree in a major category storm, that could go through plywood as well, but it won't go through metal. So metal is a stronger alternative. And tape, do not use tape because tape does nothing. Everyone used to do tape, but now that's old education. We now have new education. We know do not use tape. It does nothing to protect the windows. Now the power is going to go out at night. So how are you going to see at night? Well, flashlights are better than candles because candles can start a fire in a house. So you need flashlights and batteries during the hurricane season, or some people use portable generators. But the question there is, do you run that inside or outside your house? And it's important to realize you need to run that outside, never inside the home because of the deadly carbon monoxide gas. And of course, all of us need that hurricane survival kit, extra food, water, flashlights, batteries, all of these things during the hurricane season. And now the last topic, emergency management. So now we'll tie it all together. We have hurricanes that can threaten an area. And then we have emergency management. What role do they play? Who are they? What do they do? Well, they have an important role in our community. They're the ones that then help our community before, during, and after the storm. So emergency management, the structure, most people have heard of FEMA at the federal level. And from that, you go to each state has emergency management, like this community education project supported by the Florida Division of Emergency Management. And from there, we go to the county level. From there, we go to the city level. So what do they do? Well, they have an important role in local government. And as you read this here, they're responsible providing pre-disaster planning, training, exercises for natural hazard events, man-made disasters, and they coordinate the preparedness response and recovery actions needed for a large-scale event, let's say as a hurricane affecting or threatening an area. So an agency of an emergency management will have a director, and that director, what does he do or she do? Well, they are now the ones to provide recommendations to the head of local government in your area. So they help make those decisions on what courses of action to take to prepare for the event, like the hurricane. So they might include evacuations, opening evacuation shelters, or activating the Emergency Operations Center. So this is another emergency management is another opportunity for a STEM career for all of you sixth graders to think about as well. And an EOC, what is that? An Emergency Operations Center. Well, it's a safe place where that's now where you can coordinate all of these activities in this big room. And this picture you have is Miami-Dade County Emergency Management. And that's where all these decision makers, response agencies, contractors, volunteer agencies all come together in one place in the EOC, the Emergency Operations Center, before, during, and after a hurricane landfall to handle the event for the community. All right, so now that we've learned all about the hurricanes and what is emergency management, now here is the recommended activity for all you sixth graders and the teachers. So now, after your activity is to pretend or assume the role that you are the director of local county emergency management, and you're going to give a media briefing. And you're going to do that media briefing by recording a Zoom video of yourself with a PowerPoint, just like I did here with this module. And you're going to talk about this threatening hurricane that's coming to our area. It's a media conference before landfall, and which is typically what would be done in real life. with storm threatening our area. And so what would you put in that media briefing? Well, you're going to talk about the hurricane itself. You're going to give a weather briefing. What are the expectations and storm surge and wind? And then what are the preparations of the county? What are you doing? What decisions are you making on evacuations and closing schools and things like that? So that's the student activity that you will now do after learning all the content in this module. And I want to let all the teachers know that there is a separate activity module for all the details on how to do this activity. So you'll find it on our webpage. Go to that module to get more details about doing the activity and becoming and assuming the role of the Director of Local Emergency Management. Now, to help with all this content, some additional resources. Eye of the Storm, it's a 12-part hurricane education video series. So there's 12 videos that talk about all the content that you saw here in this module. There's the web page with the Museum Discovery and Science, Eye of the Storm, to help you now get yourself more content and from these videos to help you learn about hurricanes and emergency management. And again, we'd like to thank the Florida Division of Emergency Management for graciously supporting this community education outreach project. So there's the module. I wish you much success. Thank you for participating in the module. I look forward to hearing feedback from you as teachers and even from the students, and eventually to maybe seeing some videos of the students giving their media briefing. So thank you very much. As I said, go to the other module to get the activity, and much success, and thank you for participating.